see Jawad. He's a very known person. He worked very much in the Middle East, and I think he's CEO of Water, Energy, Climate Expert Network. I think, and he's consultant, and he's very much involved in the energy and climate project. And he's always, for Morocco, he's always there to help and to give talks, etc. And I like him very much from my side.
So much.
You know, just to tell you what I'm thinking. And I want to give you directly the floor. I think your biography is in the web page. Everybody will see it and know exactly what you are doing. I want to thank you very much for what you are doing, and it's very important to point out that you are working a very hot topic, actually, which is the problem of water, the problem of energy, and that's the title of your talk. Please, the floor is yours, and you will talk about water energy nexus, a pathway towards sustainability and net zero. Thank you very much, my friend.
Thank you very much, Sayyid Nawi, for this kind introduction and for having me here. Thanks to all the organizers for having me. It's a pleasure really to contribute to this conference. I think it's a very valuable initiative. I mean, many students, in particular researchers, don't have access all the time to conferences and to travel to attend conferences. So this, I mean, enable them to attend and to exchange with different experts without need to look for for finance to travel to attend conferences. So thank you very much again. So my conference is less technical than the ones presented by Professor Saadou and Professor Nasruddin, but again, it's important to navigate between the science and policy making. As you know, science is important. It's important to develop research, develop scientific papers. But if the policymakers don't take into account what we develop, what we publish, then we don't really do much to change things. So it's important then to really to fill the gap between science and policymaking, between science and industry, between science and society. In this regard, I will present this presentation on the topic of water energy nexus, which is not a new topic. As you know, it has been there out for like more than 10 years. My presentation is between, I mean, to show how important it is to adopt such an approach, managing both resources together in an integrated way. And it's a critical component, actually, and pathway towards sustainability and net zero. As you know, all the countries of the world are committed to net zero by 2050. So it's important to develop this kind of approaches while we contribute to the net zero and reducing the CO2 emissions fully by 2050. So this is the outline of my presentation. So I will go through the water energy security, the urgency of 1.5 pathway or 2 degrees pathway, and then I will try to go into the concept of the nexus, the challenges. I will give some concrete examples. Then I will go maybe for, I mean, to explain one of the most clear examples of nexus, which is desalination, which is a clear example of water energy nexus. And then I will go through some also other aspects related to, I mean, to also a new nexus that are appearing now, and I will end up with some conclusion and recommendations. So as you know, I mean, 2/3 of the world face water scarcity right now. In Morocco, as you know, we witnessed like 7 consecutive drought seasons, which impacted hugely our economy, our socioeconomic I mean, conditions, but also our environment. So if you look at the level of dams, I mean, this year, I mean, fortunately, we had some rain in the last week, so we got like up to 40% of the, you know, the level of water in the dams as a national average. but still, I mean, still is a water scarcity situation, still is a drought situation, and obviously this threaten our water security. Also, in terms of energy, so energy security was also in questioned. I mean, the last years, you know, with the war in Ukraine, I mean, this changed the geopolitics of energy worldwide, and we saw a lot of changes in policies, and some countries returned back to using the coal or gas, etc. So, and we know that the demands of energy will increase considerably in the upcoming decade. We're talking about 40% or even more by 2040, 2050. So this is also putting energy security in a critical situation. And if we look only at Africa, in Africa, we have more than 600 million people without access to electricity or energy services. This is huge. So we see how is critical the energy situation in Africa, but also worldwide. So we need a lot of investment really to achieve the goal of tripling, for example, renewables by 2030, which was launched by IRENA in the COP28 in Dubai. So as I said before, we committed to 1.5 degree pathway or 2 degrees, because some people or some experts think that 1.5 is already over, but still we can see if we can manage to save 2 degrees. That means that we need to triple renewables by 2030. We need to double energy efficiency by 2030. We need to cut emissions considerably, so to hopefully to achieve a net zero, zero emissions by 2050. So there are some figures provided by IRENA in terms of the current emissions and where we want to go in 2050. Obviously, decarbonizing, what we call decarbonization of our economic sectors, mean that we need to cut emissions in all our sectors. So all our sectors, so transport, building, which is also consuming a lot, like 40% of energy related emissions. Agriculture sector in Morocco, for example, agriculture is using almost 87% of our water resources. So it's another sector to decarbonize. The sector we need to decarbonize industrial sector. So, and to decarbonize such sector, we need a lot of action. So not only shifting to renewable and clean energy, but also eventually using green hydrogen, improving energy efficiency, etc., etc. So this is a big challenge worldwide, not only in Morocco and Africa. So we need to find a way to balance between managing the resources efficiently while cutting emissions and reaching net zero by 2050. The next approach is briefly explains or reflects the interlinkages between resources. I focus on energy, but the experts consider many other resources. We talk about Wi-Fi nexus, water, energy, food, ecosystem. Sometimes we add land, sometimes we add climate, but all these components are very interconnected. One action on one resource impacts the other resource. So we cannot continue managing one resource separately from the other one. Because again, because of this interlinkage. So water is used for energy in different ways. As you know, for cooling in power plants, we produce hydropower from dams, for example. We use energy for water for the whole water cycle. We need energy to extract water, to treat water, to transport water, to use in irrigation, etc. So as you see, it's very, very interlinked. But what happened in our countries is sometimes we have different kind of policies. The policy of water is in one place, and the policy of energy is another place. There is no coordination. There is no coherence between the policies, while they compete for financial resources. They compete in many ways in the different economic sectors. So the Nexus approach tries to find a way to develop synergies, to find out the trade-offs between these resources and optimize resources, whether human, financial, to manage water resources efficiently and ensure water security and energy security. So this is just another, slide where I show you the interlinkages. So as I said, the next approach has as an objective to improve the efficiency of the entire system. Another, the increasing productivity of water only, or the energy only. So it's about efficiency of the whole system. Some figures, I mean, the water sector use like 4% of the global electricity produced. Sorry. And we use like 40% for extraction, 25% for conveyance, and 20% for treatment of wastewater. So as you can see, I mean, important energy is consumed to deal with the different kind of water treatment or water abstraction or water transport. Energy consumption in the water sector is expected to double by 2040. Obviously, one of the main reasons is the increasing a number of desalination plants in the pipeline. If we look at Morocco, we are making a very aggressive desalination strategy. As you probably heard the Minister of Water and even the speeches of His Majesty the King, and we're gonna produce 1.7 million cubic meter of desalination water yearly by 2030. So it's almost 55% of the demand of in drinking water. So this is huge, and obviously it means a lot of energy, because desalination is an energy-intensive technology. So I come back to the challenges of the Nexus. What are the main challenges? Actually, we still, in our countries, in our municipalities or regions, we use the silo thinking. So everyone is dealing with its own area without looking at the overall picture, at the whole picture. So there is no coordination between different departments, different ministries, or different authorities. So that creates conflicts. That creates, concurrence on the available resources, which are scarce, financial resources, human resources, and so on. Some of the challenges are related to communication. So there is no communication between the different actors. There is no platform that gather all the players or the stakeholders to talk to each other. There are no information system. As you know, data is important. We cannot manage a resource if we are unable to measure it. So it's important to have harmonized data, continuous measuring of the data, so the decision maker can have the right data, the right indicators to develop its policy. Also, as I said, the absence of information challenge the Nexus implementation. So the Nexus, actually, to really develop this Nexus approach, we need data. We need to do the modeling. So once we have the data, for example, of abstraction of water, the use of water, the availability of water, we can then do the water balance and find a way to allocate resources. For this water will go for agriculture. This water will go for industry. This water will go for drinking, etc. The same for energy. So this is very very important. Unfortunately, we don't have such a information system. We have rather databases that are in different institutions and different stakeholders, places. So these cross-sector inefficiencies make it hard to government, to decision maker to respond in an appropriate way to the demands and the stresses. There are also some challenges linked to technologies. But I can say in our region, in Morocco, including Morocco, we have somehow, we are in a good, level of absorption of the technologies, in particular desalination technology, the wastewater treatment technologies, and renewable energy technologies. So we have some of the flagships project worldwide in Morocco, like the Noor Ouarzazate CSP plants, or like Agadir desalination plants, etc. So the technology is there. But again, we need to make sure that we have the capacities, the skills to manage such plants, such technologies, and also we need to ensure that we have also some kind of localization of the technology. We cannot rely on the international market. When it comes to an international crisis, like a war or a pandemic, then it may be a problem for our water scarcity or energy security. So we should also invest in the local contents and developing some components of these technologies locally, and oblige our partners with EU countries or companies to manufacture some of the local components locally. So just to give you quickly some examples of the Nexus, I mean, in a city, at the city level, for example, we can talk about 6 to 18% of the energy demand used to produce, treat, and transport water. So this is typical situation in a typical city. When we adopt the Nexus approach, we have this kind of configuration where we have a distributed water and power, a right mix at the right place with the right price. This is when we really take into consideration this nexus of water and energy. Another next example is, we can see here, I mean, we know that higher technology to treat unpurified water requires higher energy demand. The clear example is desalination. As I said, it's an energy-intensive technology, whether it comes to membrane-based technology or thermal technologies, we consume a lot of energy. And when we take into consideration the nexus, so we drive the cost down. That's what happened with the cost of water reuse, the cost of desalination. So in the last decade, we have really considerably reduced the cost from like $3 per cubic meter to now 0.4 cent dollar per cubic meter. So we did a lot of improvement in terms of technology to make this competitive prices. Another example is the decline in reservoir levels or dams level, which reduce hydro generating capacity. We saw it in Morocco. As I said at the beginning, because of this secretive seasons, we have some dams are almost empty, so we cannot anymore generate hydropower. As you know, worldwide, 80% of renewables are coming from hydropower. So when we have the situation of water scarcity and drought, we cannot generate hydropower, so that impacts the electricity and the energy supply. So when we adopt the Nexus, we look at other alternative. We look at renewable energy. We look at geothermal or hydrogen, etc. We look at other alternative to make sure that we don't have a disruption of the energy supply. Another final example is exploration and production, which generate large quantity of wastewater. I can give you the example of Oman. Oman, the first producer of water, is not a water company, it's PDO. It is petroleum company, because with each barrel of oil they extract with it 9 barrels of water contaminated by heavy metals. So they dispose in a very huge evaporation ponds, and which needs treatment. They cannot re-inject, otherwise they will contaminate the aquifer. So some solutions were developed, I mean, advanced wastewater solutions. I can give you the example of one solution proposed by the German company Bauer, which proposed what we call constructed wetlands. With the constructed wetlands, they could treat like 175,000 cubic meters per day of this produced water. But it's not enough. We need more effort to treat the rest of water, to make sure that this water is reused and not, then re-injected or it may contaminate our also, another very popular example is the renewable-based water pumping. So this is very popular, in particular in Africa, in many countries, in Morocco, in Egypt. We have this water pumping using PV. So this technology is proven, mature enough, cost-effective option for water pumping, and it has a lot of benefits, whether for farmers, smallholder farmers in particular, or for government. So for farmers, it provides a reliable energy supply. It contributes to improving the crop yields and food security. It help them with some incomes. It make them resilient to the climate. And for the government also, it reduces the electricity and fuel use. It also avoid the government or local authorities to use subsidize and improve also reliability of the power system, etc., etc. Another example which I've been working in for many years is desalination. So desalination is energy-intensive technology. Right now, the most dominant technology is RO, reverse osmosis, which is the case in Morocco. Obviously, as any other technology, it has some challenges. One challenge is related to the cost or the energy intensity. So this, as I said before, we had done a lot of effort. We improved the energy recovery devices. We improved the high pressure pumps. We improved the membrane quality. We improved a lot of things. And we obviously also, we had some innovation at the financial level. So we got down the prices to $0.4 as a record per cubic meter. And also in terms of energy efficiency, we did a lot. In terms of the environment, this is another challenge. So whether it comes to the discharge of the brine, which could impact the marine ecosystem in the case of seawater, and also the impact due to the intake. Obviously, we need to make sure that we build the plant in the right place without impacting, the place, or impacting the fisherman activity or whatever other activity. So when we look at the energy demand of water, we can see, for example, in Bahrain, 30% of the total energy use is for desalination. So this is huge. In Saudi Arabia, 10% groundwater pumping accounts for 10% of the total fuel consumption. In Jordan, for example, 15% of the total annual electricity generation is for the water sector. So as I said before, so we did a lot of efforts. Energy intensity in RO got decreased. So now we are reaching, the average is 3.5. But we are reaching in some plants 2.9, 2.7 kilowatt hour per cubic meter. So we are getting closer to the thermodynamic limit, which is 1.1 almost. But obviously that requires a lot of effort, and that would maybe add a little bit a decrease to the cost of cubic meter. And when it comes to the renewable energy in the water energy nexus, again, we can see here some renewable energy technologies in terms of water consumption. So we can see that some renewables like wind or offshore wind are the less consuming of water, and PV as well. So the renewable energy technologies are less water intensive compared with the conventional energy sources. So innovation in renewable energy technology is important, because innovation in renewable energy technologies impact directly this nexus, this water energy nexus, whether it comes to water pumping, as I said, or desalination, or water treatment, or water heating, and also in the end use, in agriculture, in industry, in residential, commercial, energy production. So all this is important also to use innovation to make sure the nexus is reflected in better energy security and water security for our countries. And now a combination of renewable desalination is using PV to power RO plants or RO units. As you know, so renewable intermittent, but we have different configurations. Sometimes we connect to the grid, so after the daily hours we continue supplying by the connection with the grid, or we invest in batteries, which are still expensive, but the things are improving. So these are two kind of configuration. When we compare the technology in terms of the technology readiness level and the greenhouse gas emissions, the PV RO and wind RO are the best combinations, let's say, in terms of this of technology readiness level and in terms of emissions. Solar desalination, so is the most important, as I said. So we reduce the carbon footprint, we decrease the OPEX, the operational cost, we eliminate the link between water price and the fuel cost. So we have many small scale RO plants, solar desalination plants in the MENA region. But now we will have more and more plants fully powered by renewables, like Dakhla one, which will be fully powered by wind turbines very, very soon, inshallah. Another example of the nexus is in greenhouses. So in UAE, Saudi Arabia, in Oman, we use this kind of greenhouses where we use desalination to desalinate seawater or brackish water, and we use PV and irrigate crops inside the greenhouses, and this contribute to the food security. And these are quite very popular greenhouses everywhere, and also in Morocco now, in Spain, which is very mature kind of technology. So mitigation of the water energy nexus. So we need to, as I said before, we need to push this nexus, I mean, in all sectors. The building sector, for example, we know that the building sector consumes a lot of energy, a lot of water. We need to make sure that we adopt the green building concept with the green roof, with the energy efficiency system, and also with the right insulation, with the water recycling systems. So a lot of things could be done at the level of our cities, where we can make the best use of these technologies to improve the nexus of water and energy in a way to reduce emissions, improve the use of energy, or optimize the use of energy and water, and also make sure that the solid waste is also reused or valorized.
Dr. Jawad, you have 5 minutes.
Okay, I will wrap up. I mean, I have a few slides. Thank you so much. So solutions of the Nexus. So we need sort of multi-pronged approach, which is a list, whether it comes to the demand side or the supply side. At the demand side management, we need to reinforce our institutions to support a move towards more efficient resource use, more efficiency of resources. We need to support policies that make a rational use of or rational demand for water and energy services. And we need to boost investments in efficiency improvements. This is from the demand side. From the supply side, we need to upscale technologies like the desalination, like the reuse. We need to support innovation in renewable energy. So new turbines, and new PV technology, but also green hydrogen and other kind of technologies. Supporting innovation in the concentrate management, in the brine management, because this is the main environmental challenge for the desalination technology. So I think there are technologies out there, like the extraction of minerals from such a brine or liquid, zero liquid discharge, etc. And we need to support water quality protection and storage capacity, including aquifer recharge, which is very common in like in Gulf countries like UAE and Oman. A new Nexus is now appearing. So everyone is talking about green hydrogen. I know now. Somehow we are less excited than 2 years ago, maybe, but simply because we are looking for the technology to evolve further to make the cost of kilogram green hydrogen around $1.5 per kilogram, because now it's still between $3 or to $6 kilogram or even more. But again, everyone is asking, why should we produce green hydrogen? Why should we think about exporting such green hydrogen while we don't have water? And obviously, desalination provides a solution. We have water. We are in Morocco. We have two huge coasts, in the Atlantic and Mediterranean coast, and we can use desalination to provide the needed water for the electrolyzers to produce this green hydrogen with wind or solar that we have in abundance. So we can perfectly produce green hydrogen for our local demand, but also for possible exportation to the EU market or Germany, etc. So as you know, 9 to 13 liters of water are required for the 1 kilogram green hydrogen. So this is pure water. We need additional treatment of the desalination to make sure the fulfill requirement of the electrolyzers, and then we produce this 1 kilogram green hydrogen. So, but again, the cost of desalinated water is very minimal in the cost of 1 kilogram of green hydrogen. So if you can see here, the cost of like $3 kilogram of green hydrogen, 72% is the water, 72% is electricity cost. The electricity cost is 28%, and only 1% is the cost of desalinated water. So that's give us ideas that maybe in the future we can have maybe a sort of water as byproducts. So we produce green hydrogen, and then as a water, as a byproduct, could be very cheap in this configuration. Hopefully we can have this kind of configuration in Dakhla or in some of our projects in the Sahara, inshallah. I will end up with conclusions. So the Water Energy Nexus has a profound implication for sustainability and net zero goals. For sustainability, it demands efficient resource use, reduced environmental degradation, and innovative solutions like renewable desalination, wastewater reuse. For the net zero, it requires a rapid shift to renewables, cross-sectoral coordination, and more emerging opportunities like green hydrogen to decarbonize both sectors. Achieving these goals will require obviously overcoming the challenges like policy integration, technology innovation and localization, stakeholder collaboration. So that's the requirement to ensure that the Nexus becomes a true pathway to a sustainable net zero pathway. So first recommendations. So there are many recommendations. I will not read it. So for sure, we need to invest more in R&D and in innovation. We need to involve university and research center to help decision makers to connect with industry, and we need to scale up the technologies. We need more partnership. I think there are many also financial tools like some programs like Prima program, which offer some funding for Nexus project. We need also to accelerate energy transition. In Morocco, we have the goal of 50%, 52% by 2030 of the renewable energy in the mix of energy. So this will help definitely to also to improve the Nexus, and consider the water hydrogen Nexus from now. This is It's in the area that requires deep R&D effort from now. Thank you very much, and I will be happy to respond to any question. Thank you very much.